Okay, so this tutorial is for assignment 5, and this is really related. This tutorial is really related to the last tutorial, but the point of the last tutorial was to prove to yourself that your data was similar enough that you could distribute your worms according to plan. In this case, you've collected data. You've collected worm weight and worm survival time for 3 different treatments: for control, for glyphosate, and for Roundup Ready to Use 3. And you want to know whether the worm weights are the same and the worm survival times are the same. So one of the things that I want you to notice right off the bat is that this is a very good way, when you're collecting your data, this is a very good way to have your final product stored in your Google Drive, because you've got your treatment, your worm weight, survival time. There are a couple of other ways to do it, but this is a good, solid way to do it. All right. So what we want to do now is we want to prepare this data for analysis in StatPlus. It isn't quite there yet. What I did, I just saved, because you always save. And the other thing that I'm going to do is I'm going to go ahead and I'm going to copy my data. And what I did is I just clicked across the tops, the tops of the columns A, B, C, and D. And then I hit Command C or Apple C. Then I'm going to hit the plus down here. And I'm going to hit Command V or Apple V, and that just pasted it. And now what I want to do is I want to make, so I've got all the data for control. What I want to do is I want to get all the data for glyphosate and all the data for Roundup Ready to Use. So I'm going to do the same thing that I did before. I'm going to put my cursor there. I'm going to hold down the Shift key, arrow, arrow, arrow. And then I'm going to hold down the Command key, and I'm going to hit the down arrow. And that's going to collect all the rest of the data that I've entered. I'm going to hit Command C, which is copy. I'm going to hit Command Cut. Now Excel will not actually cut the data until you tell it where to paste the new data. And I'm going to paste it right there. Okay, and then I'm going to do the same thing for Roundup. I'm going to put my cursor there on 119. So I've put my cursor here. I'm holding down the Shift key, arrow, arrow, arrow. I'm holding down the Command key and arrow down. I'm going to hit copy. I'm going to hit cut. And I'm going to put it here. And I'm going to hit paste, which is Command V. All right, now I've got my same data in 3 sets of columns. All right, so now what I want to do is I want to go ahead and I want to change my labels right here. What we really want to do is ask whether the worm weights are the same and the worm survival times are the same. So we need to change these titles a little bit. So we need to change this to control worm weight, control survival time. And then it never hurts to say what your units are. All right, and then what we're going to do, this is not control, this is glyphosate. That's not control, it's glyphosate. Do the same thing over here. This is a glyphosate. It's Roundup. And it's Roundup. All right, so now if we wanted to be, super OCD, we could delete these columns right here, because we've got our labels right here, which tell them what they are. Let's go ahead, and then it makes our data look a little neater and cleaner. And all I'm doing is I'm going to edit, and I'm doing delete, and there we have it. We don't really care about worm number at this point, so I'm going to go over to edit. I'm going to go to delete. All right. And then I'm going to hit save. Okay. So one thing you can notice is that we got different head counts over here. We have more worms in the control group than we have over in these 2 groups. Does that matter? For some stats it does, but for any complicated statistic that you do in life sciences, it really doesn't matter if you have unequal numbers. All right, so the next thing that we're going to do is our friend the ANOVA. ANOVA is very simple. And just like before, we're going to launch stat. So watch what happens with this error bar, the menu bar up here. I'm in Excel. I'm going to go down here and I'm going to click StatPlus, and it changes. I'm going to go to Statistics, and I'm going to do Analysis of Variance. Okay, if you're wondering what was fun last night, I had Zoomy drinks with my friends. Okay, and we're going to do one-way ANOVA unstack. Okay, and we're going to do control weight first. So we're going to put, we're going to do weight first. We're going to put our control weight in, our glyphosate weight in, and our Roundup weight in. Okay, and like we did last week, we're going to say yes, labels in the first row, almost always yes. We're going to look at our post hoc comparisons. This time we may actually look at them, and we're going to look at our descriptive stats. Okay. Right? Gives us this. So everybody always wants to jump to the p-value. Don't jump there. The first thing that you want to do is look at your sample size. Do these seem right to you? Remember they looked uneven with the most in control, next most in glyphosate, third most in Roundup. Yeah, those numbers match. And are these weights that worms could actually be? Yeah, 0.08 grams is a weight we've seen at worms, and 0.05 and 0.05. Yeah, that's good. Okay, so then we can look at our p-value. Our p-value is much lower than 0.05. It's essentially 0, which is not surprising because I made up the data. But you want to look at your p level. It's less than 0.05. Our f-test, you always have to report this whenever you're publishing. And then your degrees of freedom. And again, this number right here, +1, tells you the number of groups. So you had 3 groups. And this gives you this plus this plus this plus this plus 1 gives you your total number of worms. So this tells you that you had a pretty hefty sample size. Okay, so our p-value is telling us that there's a difference someplace. Oh, but look at this. That's 0.08, that's 0.054, that's 0.05, maybe 0.06. So maybe what this data really says is that this is different than these two, but that these two are the same. Intuitively, I think that that makes sense. So let's look at our post hoc test right here. So StatPlus gives us a bunch of choices for post hoc tests. We have a Sheffy post hoc, a Tukey-Kramer post hoc, Bonferroni post hoc, and a Fisher LSD. Not as much fun as you think. Post hoc. Anyway, they should agree with each other. There are more post hoc tests out there. They all have different rules and regulations. And when you take a stats class, you can get into the weeds to figure out which is more liberal, which is more conservative. It doesn't really matter. You're going to find consensus right here, or you should. So I like the Fisher because if there's a difference, Fisher usually finds it. And so you can see what the Fisher is doing. So it's comparing the worm weight, the control worm weight to the glyphosate, and it says it's different. And it's comparing the control to the Roundup, and it says it's different. And then it's comparing the glyphosate to the Roundup, and it says it's the same. You can see that's the same thing right here. P level, that's when it's less than 0.05, it's different. When it's greater than 0.05, it's the same. So it's saying those two are the same. Those two are the same. I'm sorry, that control is different from glyphosate. Control is different from Roundup. Glyphosate is not different from Roundup. Okay, so Tukey-Kramer is always not giving us an answer that makes any sense, but if you compare Tukey-Kramer to Sheffy, Bonferroni, and Fisher, you can see that Tukey-Kramer is the outlier. So we're going to ignore Tukey-Kramer. So what this statistic tells you is that you can make, you've got your sample sizes, you've got your means, you've got your F, you've got your P, you've got your degrees of freedom. Because you're doing 3 tests, 3 or more tests require that you look at your post hocs. And these post hocs, the Sheffy, the Tukey-Kramer, Bonferroni, and Fisher, tell you where the differences are. In this case, I would ignore the Tukey-Kramer because it's the outlier, but the Sheffy, the Bonferroni, and the Fisher all agree that the control and the glyphosate are different, the control and the Roundup are different, but that the glyphosate and the Roundup are the same. Okay, so there you have it. You have done a statistic, and you will report the F-test, the degrees of freedom, the p-value, and then you can just pick whichever one of these you want. How do you know which one to pick? Well, there's no right one. The only wrong one is the Tukey-Kramer. This would be a stupid one to pick. But any of the other three, have at it. Your choice. Dealer's choice. Okay? Have fun. Try it with the data that I give you.